Typically, the critical value or the decision type situation in statistics is not used very often. It still seems a little subjective. We like to base everything on probability. So we're going to do it for the p-value. And the p-value is just that. It is probability. It is based on probability or the chance. So when you do the p-value approach, what it's doing is it's going to tell how extreme the observation is in relation to the null, what I believe to be true. It measures the strength of my data. So it is a measure of probability, and that's why we call it a p-value, p for probability. And it's the probability of getting the observation how probable is the observation and all of the more extreme if the null is true. I can never tell for sure if it's true, but it's a probability is how likely is this observation based upon the null. So you have a small probability. What does that mean? Small probability means that you had a small chance of getting the observation. In other words, the observation is unlikely if the null is true. So if it's unlikely to happen if the null is true, I'm going to reject the null, knowing that I could make a mistake. A couple things about the p-value. The smaller the p-value, the stronger the evidence against the null. We'll do some examples here. Secondly, the p-value is computed from the null. That's what we were doing earlier when we were looking in the null and grabbing how likely is a $1 voucher. So the p-value is calculated using the null. Not the alternative at all, using the null. The direction of the extreme comes from the alternative. So when we look at this, kind of using some symbols here, alpha. Alpha is the chance of a type 1 error. Alpha needs to be chosen by the researcher before, that's key, before the test, and you'll see why here in just a minute. The p-value is computed or calculated after getting the observation. It's calculated from the observation. And let's just put from the observation. Now, here's the scenario. If the p-value is less than or equal to alpha, I'm going to reject. If the p-value is greater than alpha, I'm going to accept. Now, who are we rejecting or accepting? Always the null. The key here is this idea of comparing it to alpha, the chance of a type 1 error. So, for example, if I go and get data, my p-value is 90%. The chance of getting this observation is 90%. It's going to happen 90% of the time that supports my null. 90% of the time it's going to come from my null. I'm going to go with my null. What happens if my p-value is equal to 10%? A lot less likely to happen from my null, but still, depending on alpha, I might pick and stick with my null, and I'm going to do that after comparing it to alpha. If my p-value is 0.01 or 1%, I'm only going to get this observation 1% of the time. If my null is true, most likely I'm going to go with my alternative. P-value of 10% is kind of where you start to make a change, because this idea of alpha, we have some common measurements that we're going to pick. Alpha typically is either 1%, 5%, or 10%. I'm either going to be satisfied with making an error 10% of the time, 5% of the time, or 1% of the time. So I'm not going to make a change unless my data is very, very unlikely. Let's go ahead and try one of these let's do it. There are 3 studies, study A, B, and C. And the first question on here, so which study do the results show the most support for the null? In other words, my evidence is going to happen a great amount of time. Well, looking at these values here, it looks like 2.5%, 0.0018 is 0.18%, or about 35.9%. So study C supports the null. My observation is going to happen 36% of the time if my null is true. I'm going to go with my null. It's not the first time it's been tested, but we're going to use this information to support what's there. Study A concluded that data supported the alternative. So if I look at study A, 2.5% of the time this observation was going to occur out of my null. Pretty unlikely, so I'm going to go with my alternative. So the data supported my alternative. Now, in statistical language, what would this be called? A type 1 or type error? Well, in fact, my data was wrong. I should not have rejected, but I rejected and made a mistake. That is a type 1 error. If the results of study A are statistically significant says that I reject the null. Statistically significant tells me to reject my null. So when I'm rejecting my null, I'm supporting my alternative. And lastly, looking at the directions of the test. The direction of the test comes from the alternative. This says less than is to my left. Study B. Study B says that is not equal to, so I'm not sure if it's greater than or less than, so it must be two-sided. And last, if they are looking for greater than is on my right, and it's only one side. Now the difference between practical significance and statistical significance, is it practical? Even though my data may tell me to reject, is it worth rejecting or not? Is the price worth it? Is what happens changing everything worth the amount of effort that it goes through? Or is it really not going to make that much of a difference? So this concludes the lecture on Chapter 1, Part 2. There'll be another one just relating alpha and p-value.